smartphones and smart home devices are getting very popular. However, there's some security concerns. For example, privacy leaks. We all know that some devices are compromised and then be used to launch attacks to the others. So in this talk, I will address the security and privacy issues of IoT networks and systems, and discuss my recent research that provides solutions to help general users to protect their security privacy, as well as solutions to provide a scalable solution by utilizing new network technologies to combat DDoS attacks.
Welcome to talk.cybercni.fr.
Bienvenue. Welcome to Talk CyberCNR, the monthly cybersecurity speaker series. As always, also with this edition, we want to raise your awareness on cybersecurity. For me, the most important challenge, besides environmental, etc., but in computer science, the most important challenge that we have at the moment, because without cybersecurity, all the great systems that we have around us will break. You hear about attacks and so on, and therefore it's a very, very important domain. And you're exactly right that you tuned in, and we'll learn another aspect of cybersecurity today. We are today in the 14th edition already, and all the previous editions are in the archive. So on the website Talk CyberCNI.fr, you can watch them by clicking on the image 2 times. There's also the possibility to subscribe to the newsletter, and the newsletter is the only thing the newsletter sends is that each month you get the invitation to the next edition, so you get infos about that. So don't worry to put your name there. You can always unsubscribe and you will get exactly 1 email per month. All right, so that said, as usual, we are live on YouTube, on LinkedIn, and on Facebook. So we have different channels, and in order to enable you to ask questions, we use the Slido tool. The mode is as usual, so we have about 45 minutes, more or less, or a little bit more probably, talk today with Carol Fung. You see the title already next to me. And then afterwards, we have about the same time of questions. So overall, 90 minutes of exciting insights to cybersecurity. So on the left side of me, you see here you see the link. So the 14th edition, therefore it's quite easy. It's CyberCNI -14 when you go to slido.com, or you scan the QR code. As usual, I highly recommend that you participate in the Slido, because there you see the questions, you can upvote and download them, and you can follow while watching and put your questions. And as I always say, the more questions we have, the better, because then you get personalized input at the end of the presentation. All right, so today we do not have a summer school or something else to announce, and therefore I go directly to the announcement of Carol. So I'm very happy to welcome Carol Fung from Virginia Commonwealth University today as a speaker. So I know Carol for, I don't know, I think, when did we meet first? 2016, I guess, which would be 6 years already. So quite good. And it's always a pleasure to meet Carol. I'm super happy to have her today, because as a person and as a scientist and a security expert, she's great. And you will see that. And so Carol Fung is an associate professor at Virginia Commonwealth University. She received her Bachelor of Science and Master of Science from the University of Manitoba and her PhD degree in computer science from the University of Waterloo. Her research interests include network security, mobile and IoT systems security, and the next generation networks. You heard already the trailer at the beginning, and therefore, without further ado, I hand over to you, Carol, and we're excited to hear your talk, Security and Privacy Protection for IoT Networks. Carol, the stage is yours.
Okay, thank you for the great introduction, Mark Oliver. And hello, everyone. So I'm Carol Fung, and from Concordia University. It's my new position. So today I'm going to bring like a talk about mostly summarize my work from my lab about security and privacy protection for the next generation networks. So let's get started. So this talk, I'm going to start with some introduction. Okay, and then I'm going to go over like major 3 blocks of my research. First is Android privacy control, with mostly mobile phones, smartphones, etc. That section. And then I'm talking about DDoS defense. And then the next one would be the smart home networks. That is my most recent development. Okay, so first, as I said, I'm going to talk about next generation networks. But the how to define that next generation networks is
Carol, we lost you. So let me just put you back. Give me a second. So
you lost me for like a second or switch back. Oh, okay. 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 Yeah. So in this talk, I'm going to cover a few topics, which is first, the Android privacy control, which is related to the smartphone and the mobile phone and how to protect users' privacy. And the second block is the DDoS defense, which is the distributed denial of service attacks. This is a very severe problem these days. And one of my research focuses on that, how to defend against DDoS attacks. And the third block I'm going to talk about is the smartphone networks, mostly like how to help users with setting up policies to defend from the attacks. Okay, so let's start with the introduction first. So I was talking about the next generation networks. But however, so how to define what is the generation, like next generation networks? Some people may say, okay, software defined networks or Internet of Things networks or 5G or 6G networks. And it could be name defined networks or content centric networks. So actually, we can say in the broad spectrum that all of them are part of the next generation networks. Okay, so my research mostly focus on how to protect the security and the privacy of the next generation networks. Okay, for example, so when you investigate such problems, usually you look at attack vectors. So what kind of attacks are there? And what are the concerns, security and privacy concerns? And what are the solutions that can do the attack detection and the mitigation? So what I'm gonna start with, as I said, is the first is the Android privacy and the security. And this is my first block, and I'm going to talk about some of my research, which is focused on how to protect Android smartphone users from information leakage. So the okay, so let's start with some facts. Okay, so smartphones have been like a popular since like in the last 10, 15 years, and more people are having smartphones. So by like 2020, there were already 240 millions of US users, okay, of smartphones. So smartphones actually, as we know, there are several different operating systems being used, and one of the very popular operating system is called Android, and the other one, as we know, a lot of people probably already know, it's called iPhone, okay, iOS for iPhone, and in 2020, there are like 129 million Android users, approximately half, okay, and half of the users in US are using Android, and the other half apparently it's iOS. But in the nationwide, meaning all over the world, Android actually is dominant. So we're talking about 84%, like vast majority people are using Android. There are some reasons behind it. One of them is the cost, right? So Android is open source, and a lot of phone manufacturers chose Android because it's free and low cost. Okay, so when we are using Android phones, one of the most popular feature we're using is the apps. So apps is the major reason like people choose to use smartphones. So there are around 3 million Android apps. So that's actually a lot of them. Okay, so every year there are almost like a million new apps coming to the market, and their old ones maybe fade away or disappear over time. And so for those apps, the thing is, are they safe? Are they secure? So the problem is, for the Android app market, there's not much security screening. It's not like an iOS. So in iPhone and Apple, I mean the Apple company is going to do the security screening for all the apps. So relatively, their apps are cleaner, so it's more secure. But Android, basically everybody can develop an app and post it to the market right away without any security screening. So that actually opened a wide door for malicious apps to come into the market. So there was research, like actually they did some rough analysis about some apps they collected, and they found there are about 70% of the apps in the market are collecting irrelevant data. So they're trying to get data from you that they don't actually need, okay? The irrelevant data that they're collecting. So actually, data is worth money. They want to collect as much as they can. And more than 30% of the Android apps are malware. So we're talking about they actually are doing something bad, not just collecting irrelevant data. Okay. Now, let's take a look at how Android provide features to protect their users. So it's in I think everybody knows when we download the app, okay? So then when we run it, um, excuse me. So I'm going to somebody trying to call me. I'm going to stop. Okay. Let's go back. Do you still have me? I'll probably have to share screen. Okay.
So we lost Carol once again. She'll come back in a second. So yeah, once again, commercial break. We already have the first questions in the Slido. Scan the code, access it with your smartphone, and then you're able to also ask a question or to vote existing questions up and down. And yeah, so please do so. And sorry that the connection is breaking. So even though it's an overseas connection, this is probably not the reason. Hi, Alex is writing in the chat that it's an Android attack. Yes, that might well be. Yeah, so I mean, in the meantime, so it's quite interesting to see that Android and iOS have such different security models. So that Apple is doing the screening while Android is having more a distributed model for doing that. So Carol is coming back. Great. So I can yes, I can see you. I can see already the no problem. And if you start sharing your slides, no, the slides are not there yet. So I'm just doing the setup with Carol, and then I bring her back to the screen in a second. Yeah, no worries, no worries. I mean, that can happen. I just said to the audience that it's an overseas connection, and so yeah. Yeah, so you just have to restart the slide share, then we can also see that.
Okay.
Perfect. Okay, it's coming. Good. So we have you back.
Okay.
We have you back. You
Let's
can just
continue.
continue. Yes.
Okay, I'm sorry about the accident. So let's continue. We were just talking about the Android issues with Android, and the research on my lab is basically trying to protect the users. So users do have permission, have some control, is to be able to like accept or decline the app permissions. So as we already know, right, when we download the app, trying to run it, and then it may pop up to say, can the app access this permission, for example, your location, access your camera or microphone, etc. And the users do have the right to decline or allow. Okay, so in previous years, I'm talking about the older version of Android, like before Lollipop. So there's a Lollipop called the version that was about 2016, around that time. And the permission in Android was basically is I'll ask users to accept all of them. So it's like a screenshot on the left side. So when you install application, it's going to say this app is going to access this or that. You can either to choose to accept and install, or choose to not install it. So basically, it's a mandatory. You either accept or you do not have the app. Okay, so in these days, it actually improved. So you could, and then you decide later. So when you run the app maybe when the app trying to get some kind of information from your for example, the Twitter trying to access the device's location. Would you say yes or no? So let users to do it. The problem here, so this is like a very flexible version, I mean permission control these days, but there is a problem. The problem is most of the users are not very experienced. So the users tend to just say yes, okay, very quickly. There is some reason behind it. For example, users have no idea. They didn't realize the risk of their decisions. Second, they're probably in a rush. They really want to use the app right now. They cannot, sit down and think. They just choose maybe safe. They thought it's safe to say yes because that way they will be able to use the app. Maybe if they say no, probably they won't be able to use it. So a lot of people just chose yes. And there are a very small percentage of users. We call them technical savvy users. So those users actually will be very cautious when they make decisions. They will actually really think about it and make a very calibrated decision. So probably most likely, if they think very carefully, they might most likely to make correct decisions. Okay, so our research is to help the vast majority of non-technical savvy users. So how can we do to help users who are non-technical savvy to be able to make decisions that is low risk? So here comes our project called the JoyNet. So the JoyNet, the goal of JoyNet is provide a low risk recommendation, the permission granting recommendation. So let's look at like the interface. Then we can probably understand how what it's doing. So the interface on the right side is actually a pop-up window. So when the permission request pops up, JoyNet is going to insert a recommendation there. So for example, the request saying, the Telegram is request access to your phone state and identity. Do you agree? So, and the JoyNet, if JoyNet think it is not risky, so this is actually what the Telegram would need. So then it's going to just provide accept, okay, a recommendation called accept. So users actually, if the users have no idea, they probably can follow the recommendation of JoyNet. So the first thing, the assumption is the users need to trust JoyNet, so they would follow the recommendations. The question is how to make the recommendations. How do you actually have to, someone have to go there to look at every app? It is not very realistic, right? Just suppose the JoyNet probably like a startup company, and then they probably hire some people. They are able to go to each of the app and look at their permission requests and say, okay, user probably should say yes to say no of this or that. Okay. And then the thing is, there are over 1 million new apps into the market every year. So do they have to go through all the 1 million apps? The answer is no. That's how our algorithm is going to work. So our algorithm is going to work this way. So we are going to utilize the decisions from the 3% of expert users. Okay, so we need to find out those 3%, and then look at how they what's their decisions. If they decide to accept, then we probably look at multiple such users' decision, and then we can make a pretty confident recommendation. Okay, so here is the framework. How do we find them? So what we're going to use is we design the architecture of JoyNet. At first, it's going to collect responses from the users. And then we're going to look for, we call it expert users. So those users who make cautious decisions. And then we use their decisions to recommend to the other users. Okay, so the thing is, how do we find them? So we're gonna find them using the rating of users. What we do is we use a set of users we call it seed users. The seed user can be somebody hired by the Rackjoy company, and then they go into some apps, they go into do some of the permission operations, and assuming those seed users are making the correct decisions. And then we compare their decisions with the other user decisions, and to find other users if they make the same kind of decisions, which means those users are expert users. So we start from the seeds, and we can find a set of expert users, and then expert users probably has a lot of apps. So as we know, like average apps on the phone, it's like 60. Okay, so we have a lot of people have a lot of apps. So and those users probably install the other apps. Okay, so since the expertise level typically is consistent, right? If you make the good decisions, usually it's pretty even across all the apps. So we can use that to extend our coverage of apps. Okay, so we start from the seed, the apps covered by the seed, and then we find other expert users, and then we are able to cover a much larger set of apps. Okay, so that's the basic ideas. So here's the model. The challenge is how to establish the mathematical model so that we can quantify the user's expertise level and quantify the decision model. Okay, so let's try to illustrate how this works. So we have on the right side, we have the figure. You can see that the circles are users and the squares are the apps. So S is the seed user. So let's say seed user cover a small set of apps. Okay, so C and the D actually are covered by the seed user. And then the other users, like say 1 to 6, okay, the 6 other users, and they all cover some apps. And in particular, user 1 and 2, these two users, they have the common apps with the seed users, so which are C and D. So we can see that user 1 installed A, B, C, D. Okay, among them, C and D are covered by the seed users, which means we can use the decisions of C and D and compare their the decisions with the seed user, and that way we can actually have an estimation if user 1 is expert users. Okay, so similarly, now user 2 has one overlap app with seed user S, which is D. And all the other users, like 3, 4, 5, 6, they have zero overlap with seed user. So here, what we can start with is we start from user 1 and 2 and give them their rating. So we call T1 and T2, which means a value like how good they are. And we can establish a mathematical model trying to calculate T1 and T2. And then after that, okay, let's say we already know user 1's expertise level is 0.8 and user 2 is 0.7, for example. And then we can see like user, let's say, the other users may have overlap. For example, user 1 and 3. User 1 and 3 share the two apps would be A and B. Okay, let's say we compare the decisions of user 1 and then the decisions of user 3 on those two apps. We can actually be able to rate user 3 that way. So like in that way, we can actually expand further and further. And then we can rate a lot more users that way. So let me show how the model works. So here we look at the scenarios, like how we are going to do user expertise rating. So here we can look at, okay, user S and user I. So let's say user S and I has overlap apps, and then we call them has a connection. So here, so how much is the connection? We use two parameters called alpha SI and beta SI. So alpha SI means the number of agreements. So they are the user S and the user I found like a number of the matching decisions, which is denoted as alpha. And the beta is the number of mismatch. So they do not agree with each other, is beta. So apparently if alpha is large, they are more similar, okay? And the beta is small, then they are very similar. Yeah, otherwise, now if beta is large and alpha is small, which means they disagree and they're not similar. So in that way, we are able to give mathematical model. So we use the model called the beta distribution. So if anybody have learned now in the statistics, probability and the statistics. So beta distribution, basically, it's called a prior conjugate prior distribution of Bernoulli. Okay, we know Bernoulli distribution, right? So basically, like we're tossing a coin. Okay, the coin maybe can be head, can be tail. It's the binary. However, the coin is uneven coin, which means the probability of head is not half. It probably is another number. For example, 0.9. When you toss 90%, it come out to be head. But we don't know the number we want to estimate. What is the probability that the head gonna show up? So in that case, then we can do is to do experiments, right? We toss the coin many times, and then we can have a good rough estimation. The more you toss, the estimation is more accurate. But how do we mathematically model it? So actually, it's model called the beta distribution. So the beta distribution takes two parameters, alpha and the beta. So alpha, which means, okay, so the tail, okay, beta means the head, for example. Then when we collect the alpha and the beta, then we can draw a probability of the Bernoulli variable. Okay, so we can see in this figure, we can have like a alpha equal to 5 and the beta equal to 1. So then we can see it's the blue line, is the distribution of the Bernoulli probability. So here is, and we also developed another formula to calculate the confidence level, which means that how confident is your estimation. So confidence level is directly connected to the alpha and the beta, which is the number of samples. Now, when we do more tossing, then we are more confident, right? So our estimation is going to be more confident because we did more experiments. So that actually reflects into that CI, the confidence level. So if we have more apps overlapped, if the user I has more overlap with the seed users, then we can give a more accurate estimation of the I's expertise level. So we can use CI. How do we develop that? Actually, that's described in detail in our paper. You can refer to our paper for a lot of details. So similarly, we also developed other scenarios. For example, the users do not have direct overlap with the seed users, but they do have overlap with other users. In our example, previous example, like a user, if we go back, so that's basically user 3. Okay, user 3 doesn't have any overlap with the seed user. How can we estimate the user 3's expertise level? So that's, we also developed the formula for that. and which is shown here, is basically we need to know like that user has connection with a rated regular user. So if that user is rated, okay, already has a expertise level, and if a user has connection with, or we call it overlapped apps with that user, then that user can also be rated. So the formula actually also developed, and we can, it's shown that here. And let's look at the other case. Let's say we have multiple users connected. Okay, so for example, user, like some users, they do have they have connection with multiple regular users. Excuse me. So, and also, for example, also have connection with the seed user and the connection of the regular user. So in that case, we also covered that case. So we called multiple path. And we also have multi-hop in scenarios. For example, like a user J has a overlap with user I, and user I has overlap with the S user, like seed user S. In this case, we can also come up with a formula, okay, to calculate the multi-hop scenarios. And note that the confidence level drops significantly when there are multiple hops. So we also use, like here in this graph, we trying to illustrate like the rating process. So we start from S in the middle, S, and then after first round, and all the users around S is going to be rated with expert rating. And after another round, okay, after the second round, then more users are rated, which is the second level here. And then if we keep calculating, and then some users gonna be updated again, because for example, previously the third level users, okay, were not rated. So after they're rated, actually they can come back to influence the second layer users. So we developed an iterative computation mechanism. So we keep calculating, keep updating the expertise estimation for all the users until it's reaching a stable status. So when the whole rating is stable, then we say, okay, we are done. So we actually converged to a stable value for all the users with expertise level. Okay, so after the rating of all the expertise levels, we do want to come up with a recommendation. That's what JoinNet is doing, is to come up with a recommendation, right? How do we do that? We call using a weighted voting. So first, we're going to do a filtering. So we set a threshold to say, this is a threshold. We only consider the responses of the users who has a high expertise level. So we're trying to focus on the top level users. So there we consider them to be expert users. We need to find those, and then we look at their decisions. Somehow their decisions are conflicting with each other, but we do have a way to deal with that. So we call it weighted voting. So those experts are going to make decisions, and then they will use a weighted average of those experts, and then we are going to make a decision. So if those experts conflict with each other, what's going to happen is then we calculate the weighted average. It turned out to be like a 0.5, which means we cannot make a decision. So if there is they do have if they all most of them go one way, for example, most of them say did accept, then the weighted weighted voting results is going to be relatively high. So we use a tau to
it worked quite well for a while. So let's see Carol come back. And in the meantime, as in the previous breaks, you can go. Yeah, Carol, we lost you once again. Let me just put you back. So yeah, I mean, it was not long. It was just like 10 seconds. So if you can just go a little bit back, that would be great.
Okay, 10 seconds. Okay.
Yeah, so we are ready when you are. So just let me know.
You good? Ready to go?
Yes.
Okay. Let me go back a little bit, wind back a little bit. So we were talking about the weighted voting. So everybody going to have a decision, like we said, we found a set of expert users, and they all made a decision on certain permission requests. Okay. For example, some of them, no, they all unanimously said accept. Then the weighted voting results are going to be accept. If some of them say yes, some of them say no, and then we need to have to calculate, use the weighted voting. So weighted voting is the first they collect their votes and then multiply by their rating. Okay, so called the TI is their weight. Weight is basically is their rating. So if they have higher rate, then they carry more weight. So we do this, and then we look at yes, number of yes, and a number of no's, and then we to see that like yes over yes plus no is higher than a threshold tau. If it's higher than a certain threshold, which means vast majority of them said yes. So in that way, we can accept. We can provide a recommendation. It's called yes. Okay. If those experts they conflict very badly, for example, 50% said yes, 50% said no, and then the weighted voting is going to be close to 0.5. Then it's not going to exceed the tau threshold. Then we would choose to reserve our recommendation, not to make a recommendation unless we are confident with our recommendations. Okay, so similarly, so we can do reject the same thing if everybody unanimously said reject, and then the recommendation is going to be reject. And if some said reject, some said accept, then in that way, then we have to see if the weighted voting is smaller than a tau, 1 minus tau, a threshold. And then if that's small enough, which means vast majority said reject, in that case, we can recommend to reject. Otherwise, we are going to reserve our recommendation. Okay, so we implemented our JoinNet in the app mode. Okay, so the users are able to install the JoinNet application and enjoy the recommended permission control decisions. So this actually app was developed by and was started by my PhD students who designed the algorithm, but it was actually completed by another master student who graduated after the PhD. Okay, so next I want to briefly talk about is XJoid. So we developed a more a mature model for the recommendation. The reason behind it is we're talking about the starting point. So at the beginning, okay, when you have an app, so nobody is actually Very few people are using it. So we cannot make a recommendation if we do not have any input, right? Now, what we could do is we can actually develop a machine learning model, and we can have some initial recommendations. For example, we can use start with a set of malware that we already know, and then we look at those malware's features and activities, and then we compare it with the current app we have, and to see if there are any similarity in terms of activities. And how to compare it? We can use a model called the hidden Markov chain. Okay, so here in XDroid, that we call it XDroid, basically is use a machine learning model trying to provide recommendations on those apps, and which is more advanced than our previous model, which is weighted average, which is really simple. Machine learning model is established this way. So we have two status. One is benign, one is malicious. Okay, so the apps can then can choose to behave benign and then behave malicious. Apps can always do something bad. Okay, sometimes, not all the times. Okay, so sometimes they're doing fine. And then we can record their activities, okay, their behaviors, and then we use the hidden Markov chain model, trying to eventually give a rating of the app depending on how many malicious behaviors that app can have. So the the model is actually shown, like illustrated in the graph. We can see that their status and their observations, which is O1, O2, and then we can use those observations, come up with a probability. It's called emission probability B, which is going to be given to an app. Okay, so the probability B basically it's a value, okay, between 0 and 1. So if it's high, which means it's malware, which is more likely to be a malware. If it is low, then it's benign. With real apps. So we collected the malicious app dataset from from the open source, which is called the Drabbing project from Tigen. Okay, so they have over 5,000 malicious apps in their dataset. Among them, we picked 700, basically because they have categories. We picked some from each category, and we put them together. It's 700 malicious apps. And then we also get 700 benign apps from the App Store. So the App Store, basically, there are some trusted developers or trusted sources that we can use to say those apps they should be benign because they are from trusted developers. So here we combine them together. So we have 50% malicious apps and 50% benign apps. And then for those 1,400 apps, we divide them into two groups. By
All right, so interesting research, and we lost Carol again. Sorry for that. But as before, she'll be back in a second, I guess. In the meantime, we can already have a look at the Slido. So there's already a lot of questions, a lot of interesting questions, and it's also an interesting and important topic for each of us because we all use the smartphones every day, and a central challenge is always if you have users that are not so experienced, and such collaborative approaches. I'm a big fan of those, and I also apply such techniques from time to time. to security problems and also to other problems, and can be quite helpful. At the same time, it's always interesting to see how you weight what different users say, how you combine the input in order that you don't get biased, you don't get attacked about it. So we also have already some questions in that direction in our questions. So yeah, okay, see, Carol is not coming back. Alex is coming. Very good. So yeah.
The score after training, okay, and then we can apply to the 400. We found that we were pretty much,
so I don't know, Alex, you
able
have any
cluster
points
the
to
malicious
the
apps
talk
to
so
a
far?
higher
As usual, we
score
fill the gap
for
with some
the
discussions.
but
Yeah,
we also
thank you,
see
and hi,
that
Mark,
there are
Oliver.
some apps
Yeah, so
are
very
having,
interesting presentation with a lot of technical details and a lot of
so but
general information
roughly
about
we're able
the
to
use
separate
of Android
them
smartphones
using
for the world.
threshold, let's say
So
0.7.
as far as
Okay,
I
if we
am
set
looking for
0.7,
questions,
we
I've
can
seen lots of
find
questions
that
about on
like
Android
90%
and about
of
the
some
security
malicious
policies.
apps can be
Possibly coming
classified.
back. Let's see.
And but there are some false positives.
Okay.
Some normal apps
Yeah,
also
yeah.
got
So Carol,
classified as. Yes,
yeah,
lost
we
me
lost you when you've
again.
been to the 1,000 users. So it was about
Oh,
a
that
minute
was the
ago.
last.
Yeah, there you were showing the
Last slide.
slides and you were we're talking about these thousands of users that are giving input, and so if you can go roughly back to that, that would be great.
Okay, let me go back then.
Yeah, and besides that, we just said we already, Alex was just talking about lots of questions that we already have, which is quite good.
Let me share the slide. Let me see which one is it. Okay. That's good. Can you see the slides?
It's coming, yes, we see the slides again. And
okay, so that's wind back a little bit. Okay, so we said we have among 1,400 apps, and 1,000, we put 1,000 into the training and 400 for testing. And then we developed, our lab developed called the app logging tool, which actually we be able to capture all the behavior statuses of all the apps when the app is being run, okay, in the sandbox. So when we collecting the data, we let apps to run 2 to 5 minutes, like randomly, and then we add human interactions. Okay, let's say we simulate the user actually we're going to play with the app for some time, and then their behaviors gonna be logged by JoyCat. So with those data, we were able to come up with some results, and just trying to highlight some of the results here. So for example, use the hidden Markov chain model, we're able to give like the score, okay, the malicious score. And then we can see that for the malicious apps, we noticed that we were able to be able to the malicious apps tend to have higher score, malicious score. So here we among that the number of apps, 450, and then we have we found that some of the apps, then benign apps, has also have high scores here. Okay, so but most of the benign apps gonna have a score which is relatively lower, between 0.5 to 0.7. So here we can see that if we set up like a threshold like 0.7, we can nicely separate the malicious app and the benign apps. So for here, we can also see this distributions here and distribution like malicious apps here. Okay, so there's some other results in terms of choosing the threshold so that we can divide malicious app and benign apps here. And we have also tested some other parameters here, but I'm not going to go through them. So there are some other publications our labs has done about joint-net relevant publications. Like, for example, we all in the smartphone apps, and we also have secure application recommendation system. Like we're trying to provide a security score of the apps in the market, and we also use others. So for example, we have JoinNet is our main paper. It's trying to use recommendation system and provide recommended permission control decisions, which is published in IM 2019, and a few others relevant ones. I think we're gonna move on to our second block, which is denial of service attack, which is also one of my major focus in the last few years. And we all know about denial of service attack, right? Which is pretty like common knowledge. Attackers like to send a huge amount of traffic, and that traffic is going to overwhelm the victim. So victim usually has a server, okay, and the server is called a production server. And if there are a huge amount of traffic flooding in, the server may drop or stop working because they cannot cope with the huge amount of traffic. So that huge amount of traffic is called the denial of service attack. Okay, so there are already, because this has been there for a long time, there are already a lot of solutions. Let's briefly look at the solutions here. And the solutions divided into the source side solutions. Basically, if you have heard of the egress router, so they can enforce egress router to say, okay, you are going to make sure whatever the packets coming out of your subnet cannot use fake IP address. So this actually, if that can be enforced, okay, if that can be reinforced, then a lot of DDoS attack can be eliminated, because one type of DDoS is to use fake source IP addresses like a SIM flood, okay. And another type is called human verification, which means make sure there's a human behind each of the requests. So that can be useful in some cases. For example, the login. Okay, so in the bank account, in the bank servers, they are always password guessing. Okay, attackers trying to use the bots. Okay, to make connection and then trying to guess the passwords. And if you let them guess, at one point they will succeed at some point. How to block those kind of attack is basically you're trying to use called captcha. So the example of captcha on the right side. So this kind of captcha is actually more modern, like more effective ones. It's basically saying, okay, among the pictures, can you pick out one picture that what I'm looking for example, a cat. Then you can pick all the cats, okay, among those pictures, like that. So those can actually effectively block the traffic which are generated by the bots. So the bots basically are the traffic which is not generated by real human. It's generated by robot, okay, by a program. So they probably will not be able to, most likely they will not be able to answer those captcha challenges. However, not all of the cases we can use captcha. So a lot of cases you just cannot stop and ask them to put the answer captcha. So in that case, we cannot use captcha. And the traceback, which is a very very good solution if there are a lot of cooperations. Traceback basically is to look at the root, okay, find out which path those attacks coming from, and trace back to the source. And if the source now turn out most of traffic can trace back to one source, then apparently that's the source of the DDoS. Then we can just block that path. So, however, there is a problem with the implementation. Is it needs the cooperation from a lot of routers, okay, in the internet. So, which is not a very practical, because the routers belong to different companies, okay, and it's hard really enforce them to work together to find the source for you. Most practical solution these days still is the defense from the destination side. As a victim, apparently there's incentive for the victims to protect themselves, and but when you protect on the destination side, which means that's already like all the attack traffic already like gathered. Okay, you cannot block them at the source, you cannot block them in the middle. So, but you can block them by the gateway. So, what can we do? Okay. The most popular solution these days for small like enterprises, we call them use DDoS cloud services. So small companies, as we said, that they don't have a lot of resources. Okay, they probably have some, but they're very limited. And however, they can do is to forward their traffic to a cloud service. For example, Cloudflare. There are some other like commercial services. Cloudflare is just one of them. There are a lot of competitors like Microsoft Azure, like AWS Shield, etc. Actually, a lot of commercial products to do similar things. They all allow you to forward the traffic to the cloud service, which is has a very advanced DDoS filtering algorithms, and they can do it for you. And then after their filtering, they can forward the traffic back to your protection service. That way, it can be very effective, but there are problems. What are the problems? The first, so if you have to forward traffic to a third-party Cloudflare proxy, okay, as the cloud service, there is a latency. Okay, there are actual latency, which means you have to go all the way to probably some cloud farm pretty far away and then come back. There probably you're talking about adding some maybe a second of delay. And then second is the trust issues. When the company has to forward everything to a third party, do you trust them? So do you trust them like to do not steal your information? You probably have to, because if you have no choice, you have to trust them. And the third one, it probably is one issue for some companies would be the cost. Excuse me. The cost issues. So the cost is basically they do not provide service for free. They are going to collect some service fees. For example, they charge by subscription, or they charge by the volume you are sending to them, etc. But there should be a cost. Okay, so what we provide, our lab actually provides some kind of solutions, which is alternative solution. So we know that not all the companies want to forward the traffic to a third party. They probably want to handle those excessive traffic internally. But how to do that? So we propose a solution which actually can allow them to use their actual resource to handle those traffic. So our solution is built based on called NFV. So if some of you probably heard of it, it's called virtualized networks. So the network resources actually are built upon some commodity servers, and then they build a virtualized network served upon the commodity servers. And in the virtualized network, the good thing about it is very flexible. It can create some network functions instantly. Okay, so they can create, for example, I can create like a virtual router right away, or I can create IPS, IDS right away. So basically, it's very flexible. So in this, our solution is we allow users to create multiple agents. Those agents are equipped with DDoS filtering functions, for example, to do the dedicated handshaking to block DDoS, like a SIM flood attack, etc. And can use the blacklist or use the algorithms to calculate the probability score of bot traffic, etc. And those, they all need resources. So we can dynamically create those agents to handle the resources. And then the filtered traffic will be finally go to the protection service. So this way, now we can, in this way, we are able to do a dynamic DDoS defense to scale that will not overwhelm the network.
So
this
you
is
have about 3 minutes, Carol, just to tell you, because then we still have
okay.
time for the
I'm
questions.
going to,
Yeah,
I'm going
it's fine. It's also super interesting. I just wanted to tell you, like, if you
Okay.
finish in 3 to 5 minutes, then we would still have some time for questions. Great.
Yeah, sounds good. So here, what we can do is to, what we're going to do here is to develop the algorithm. We call it dispatcher. So the thing is, dispatcher needs to remember the packets, like the which uh, which agent it forwarded the traffic, and they make sure the packets in the same flow is going to go to the same agent for handling. Otherwise, there would be a disconnection, so it would be a problem, a networking problem. So then there's a challenge here is how do we make sure, and when under the DDoS attack, there could be a lot of different flows, and those flows gonna overwhelm, we call it a forwarding table. Okay, the forwarding table, usually we're talking about thousands of entries, but under a DDoS attack, there could be like a million different flows, because those sources are created randomly. So how do we handle them? So we actually propose not to do a flow-based routing. We use a bucket-based routing. So for each flow, we are going to generate a bucket number, use a hash function, and then in each entry, we call each bucket, we can handle multiple flows so that those flows go to the same agent. So in this paper, we basically talk about management, how to manage those buckets, and how to split buckets, how to merge buckets, and how to handle the overflows, etc. So a lot of details actually inside the paper. Okay, so briefly look over another work we have done is called co-fence, which is looking at a larger, medium to large volume of DDoS attack. And if the internal resource of a network will not be able to handle the traffic, then another option is to forward it to a third-party resource. But third-party resource we want to look at, like the called a domain help domain. So some domains, they may trust each other, and they can share resources with each other, so that they do not have to go to a Cloudflare like the online services. Actually, in that way, they can actually look for the alliance which is in the close proximity, so they do not have to forward the resource, the traffic to too far away. They can forward to close by proximity alliance. So the thing is, the prerequisite is they do trust each other, so that they do not have to worry about the privacy breach. Okay, so our research in this work is focused on how to design the cooperation model so that they can help each other with incentive compatible manner. And we also care about the fairness and care about reciprocal, which means if if one of the member helped you more, you should help them back in return, like that. So how to design this model? We use we call the Stackelberg game. We use the game theory to design the cooperation model, and I'm not going to go through the details of the model, but when we use the model, we can we prove that this model, under this model, there is a Nash-Euclidean, which means there is a stable status. Under stable status, and the system do satisfy the incentive compatibility and the fairness and the reciprocal relationship among the cooperators. Okay, so there's some other publications on the DDoS defense. As we list here from our lab. And the third model is called smart home networks. And this is a new research from our lab. And so far we have done is to set up a network to allow smart home users to share the policy. Like, for example, the policy to block certain attacks and the policy to turn off and turn on some of the devices, etc. So those policies typically, if you set up policies, most likely the other home users want the similar policies. Then you probably want to share with others, or you can borrow from others. In that way, but how to share and borrow from others in a very efficient way is our research focus. And we have one publication which is mostly focused on the propagation or how to share those policies of the home users. And I'm not going to go to the details because we have the paper. If you're interested, look at the paper. This is our research. I think I'm going to wrap up. I don't think I have time to go through all the details of this model. Just go to the summary. So in this presentation, I basically looked through the three aspects of our research in our lab. And the first one is the smartphone privacy control and the security protection. And second is the DDoS mitigation solutions. And the third one is the smart home networks. And welcome anybody. If you have questions, let me know. I will be happy to answer.
Great. So thanks a lot, Carol. I clap my hands in representing the audience that you did not see. And in the questions, we have lots of questions. We see already that your talk was very well received, and I personally enjoyed it a lot. So as usual, let me ask the first question. And I thought about which one I start with, but I'll start with a quite general one, namely, you talk about app economies, mobile phones and apps on these, and then you talked about DDoS, which is more, I mean, it can also be in the smartphones, but also in the classical IT sector. So which are the biggest differences between these mobile systems you were talking about and the classical IT infrastructures regarding cybersecurity?
Yeah, the mobile system is part of the entire internet network, and there are two blocks, and they are actually pretty they have some connections. For example, like and the general like DDoS attack, actually a lot of them involves Internet of Things. Like attackers are more and more coming from some IoT devices, such as the cameras and printers and routers, etc. They can be attacking sources, and it could be an interesting direction to investigate. Yeah, but they are kind of a separate focus. Yeah.
Okay, cool. And as the audience already sees, and the setting is quite cool because we have 4 people now for the discussion, including you. And therefore, I hand over now to Alex, who has a PhD from the Cyber CNI chair and is currently as a postdoc in Nantes, and Akin, who is currently pursuing his PhD in Munich. And punctual to the questions, we lost Carol, but there she's back. Okay, so Alex, I hand over to you. Carol, can you hear us?
You got disconnected for like probably 10 seconds.
Yeah, no problem. If you can
On
hear
my
us
side,
now, it's perfect. I just introduced the two moderators for the question, and then I hand over to Alex for the first audience question.
Thank you,
Okay,
Mark Oliver.
yeah, sure.
And thank you, Carol, for this very enlightening presentation. So there were a lot of questions, and I will begin with the more general question about Android and Google on iOS. The first one is, do you think your research could be integrated to the Android Google Store ecosystem? And is this your ideal?
I think this could be. I mean, there's a potential if they think that's a valuable product for them. Yeah, actually, we were thinking about having a startup company with this, but we just end up not really have the energy on that. But we publish everything we have, and hopefully can inspire the other researchers and provide some valuable aspect, some views of the security and privacy. Yeah.
Okay. And another question, I don't know, it's about the beginning of the presentation. So why do Google and Apple have so different approaches to security?
Google and the Apple, it's yeah, that's a very interesting question. I don't know why they chose different way, but I think what I can think of is for Google, because their products based on like sandbox, the virtual machines, right? If you know how like their the phone architecture, the smartphone architecture, so their Android is built based on sandbox structure. So all those apps, they are naturally separated. They are like mini they are like a mini virtual machines running in parallel. So their connections to each other, you have to give the proof to each other. For example, app 1 wants to read something from app 2, you have to explicitly allow them to do that. By default, they are totally separated. So it's pretty relatively safe, I would say. If one app now is trying to do something harm, there's a limitation. They cannot do too much about it because they are separate from the other apps. Okay, so about Apple, as far as I know, their sandbox, it's not totally, no, I know the code is running on bare-bone machine. Okay, it's not like in Android is the Java virtual machine. They're running on Java virtual machine, but on Apple they're bare-bone running on the hardware. Yeah. So I think I don't know about a lot of insight, but I think that probably make it less secure.
Yeah. But maybe the store is more complicated to put an app on the store. So
yeah, I guess if they allow malware to run on their Apple phone, they might be able to potentially do more damage. So they have to make sure all the apps are clean, when they're
So another question about these two big operators. Will be smartphones more and more essential to everyday's life? And if yes, how bad is that there is only Android iOS monopoly or oligopoly?
Okay, yeah. Yeah, interesting, very interesting question. So Android monopoly eventually end up not, they do not listen to the consumers, right? Because they are the only choice. If you have competitors, they have to be afraid that consumers gonna have another choice. They will choose the other option. So I think it's not good if there's only one Android in the market. They should be consumers should have a different choice. If they want to make a choice, they can switch to a different product, and in that way, I think the phone providers maybe will listen to consumers' feedback more that way.
But related to that, do you think your consumers are actually aware of that there are two major operating systems, or the majority of consumers that there are two main operating systems and that the ecosystems are different? the question obviously goes into the direction of awareness of cybersecurity. So
yeah, I agree with you. So users needs to know they have options, right? If they don't know they have options, then apparently they probably, they are by default is, oh, I can only use this phone.
yeah, exactly.
That's not
Because this is what I see with my parents. I mean, they use Android, and when you give them then a Google phone, it's like and an Apple phone, it's like, oh no, the interface is different, and we cannot use it anymore. Please give me back the other phone. So it's as usual, like the decisions are not based on security features, but more on different internal architectures, but more on the user interfaces and so on.
We also aware that most users, they have no idea of security, no idea the security is very important. They know it's important, but they just not. They still put the usability and the function as the first option, the first criteria when they choose to use app or not. So I think the security rating should be in more prominent position, so let them see, because currently they don't know about the security, how secure the app is, unless they actually read all the reviews. But a lot of reviews are pretty superficial. They just rate how easy to use, how many functions it provides, etc. Very few people can comment on the security aspect of the apps.
Okay. So I will just follow with a few questions again about Android. So there were questions about the beginning of your presentation about why are you working only on Android? How can we secure Android better? And a more general, a more precise question was, is it possible to provide by default high security rules to Android and App Store instead of giving users the choice of clicking if I accept or not to give some information?
Okay, so I try and look like you have multiple questions, right?
Yeah.
Can you remind me what's the first one?
So the first question was about why are you working only on Android and how can we secure Android better?
Okay, we chose to work on Android because it is public, open source, and it's easier for us to actually look at the source code. And the iOS is not open source. We don't have the source code. We have very limited understanding of the architecture, etc. And it's for them, it's a secret.
Okay.
So that's why we choose to work on Android. Yeah, and Android is a more secure problem. More security problem is more prominent in Android because they don't have a screening, the security screening of the apps. Yeah.
Okay. The question was about, as you showed Lollipop operating system version, I have to find again my question. Okay. So is it possible to provide by default high security rules to Android instead of giving users the choice of clicking everywhere to give access to every data?
Yeah.
So to have a more secured by default iOS operating system rather than to let the choice?
Yes, I think theoretically it is possible if you are able to, for example, like be able to understand the context of the program and then look at their the goals and then look at the implementations. I think it's possible, but very difficult task for the automated program to do that. And it's easier for users to make decisions because users can actually look at the functions and the description, understand the context of what the apps is for, and then when the permission pops up and the user actually can analyze to see, oh, this makes sense or not make sense. I think some users can do that. Unfortunately, currently, I think it's pretty difficult to automate that decision process. I mean, it's probably possible, but it could be an open research topic.
Okay, thank you for these answers. So I think we will switch questions and presenters. So it's your time, Akin.
Okay, thank you. Actually, first of all, I would like to maybe pose the audience questions a little bit. I have a question. I would like to start with that. So when non-experts, for example, ask me an advice, like a golden rule, just tell me one thing that I can secure my phone, my computer, like IT security, golden rule. And simplest thing I can think of is well, always keep your software up to date, your operating system up to date, your applications up to date, all the software you use should be up to date. Very easy thing to do. You don't need to be an expert, and don't forget this rule. So what do you think? How important is this golden advice? Is this really golden, or is it really overestimated?
I think this is a keep software up to date. It is definitely nothing wrong to do.
Mm.
I mean, in very rare cases, when you update your software, it turn out to be opening another bigger loophole. Or it happens occasionally, but in general, that's the right thing to do to keep your software up to date, because a lot of times the software and upgraded version usually trying to close some security holes of the previous version. It's very typical, and they sometimes add more functions, but a lot of updates are security related. They're trying to close up some of the
Um,
vulnerabilities, so to make your software more robust and less likely to be attacked. Yeah, I think it's good. It is a good practice to
yeah.
keep software up to date. Yeah.
Yeah, it's a good habit. I would also, I mean, some people argue that you should wait a bit before update because every update may also introduce you new
Yes. So
bugs. But yeah,
that's
there's a
another
trade-off.
argument. Yeah, you do not want to be the first one to do it. You probably wait a
Yeah,
little
yeah,
bit. Yeah.
exactly.
But there's a balance. How long do you wait, right? If you wait too long, probably you got attacked. If you probably don't want to be the very first one to do it, that's understandable. Yeah.
Uh, the next question that really drew my attention that comes from among the audience, I think it's more research-wise. Like, how do you choose the models that you apply?
Choose the which model.
For example, the models you presented during your presentation and the papers, how do you pick them?
We basically, it's for example, the model for user expertise rating. It's we just trying to find the solution. We identify the problem. Let's say we really want to find a way to rate the expertise level of smartphone users. How can we do that? So we first look at what we have, what kind of input we have, and what kind of output we want to obtain, and then we find the suitable model that can produce the output given the input. Yeah, so that's basically, there could be very different approaches. We picked one with which think we make sense, and there could be many different ways to solve the same problems.
Mhm. Yeah. Related to collaborative security approaches, for example, one question is, how many users does it need to apply your collaborative security approach? Probably as much as possible is better, but
Yeah, so users collaborative. Okay, for that one, we usually look at least three. Like if it's two, it doesn't really make sense, because you have
Mhm.
now if when you have three, then you can say, okay, I give resource to collaborator A or B. So you have choice, right? So if the two, the only
Mhm.
like the only choice is one, then there's not much to incentivize. But if there are three, then it's okay. If you do not provide resource to me when you ask for help, and I'm gonna give resource to the other one, like that, and then you have choice. Then that model works. The game theory model works.
Very related to this, are the collaborative approaches you were talking about already implemented? What would be necessary to bring them to the market?
That one actually we trying to implement it. I had a student working on that, and yeah, he actually made some breakthrough. He said, okay, there's a very challenging thing is to how to make the how to say that the handshaking, TCP handshaking. He needs to hack into that, so he doesn't have to change the whole TCP protocol. Instead, he actually trying to be able to uh, trying to wind through it, and was able to add some programs and do not have to change the kernel, and was able to change change some of the parameters, and be able to do the handshaking part uh, for the collaborative DDoS, because collaborative DDoS, this one key part is to do delicate TCP handshaking. Is trying to block those fake the SIM packets with fake source IPs. Then you have to do handshaking, delicate handshaking. So that's actually the challenging part, and it's doable. We haven't finished yet. That student graduated. Unfortunately, you have to look for somebody else to replace him to finish the project. But it is doable, and in some sense. So we're able to do to delegate using another resource to do delegated handshaking. Yeah, so we're still working on that, but we know it is doable.
How do you prevent bots from spamming and destroying your ratings? This is also quite a severe problem, I would say.
How to provide the bots? So even you go back to the smartphone section, smartphone. Okay, so we have one paper talking about the bots because the ratings that can be cheated. So, for example, the app creator, okay, the app creator trying to really want to get very good, like trying to create a few fake expert users, and then the fake expert users say yes, accept those permissions, say yes to all of them. If they successfully did it, use the bots, and then the system will recommend everybody to say yes to those permissions that actually should say no. So we actually did have a a paper to address that possibilities, and that paper is trying to detect such kind of bots based on their correlation, like because bots, if they do the fake decisions, and they tend to have some correlation. They kind of, because they're bots, they actually programmed, so they have a lot of correlation in terms of their rating behaviors and their decisions pattern, etc. So if we find those spots, we can just ignore them, and their input will not be accepted.
Maybe one last question from my side. This also, I find it quite interesting. So how can you handle different versions of the same application? Because as an example given in the question, an app may establish it as legit, then adds bloatware afterwards, which has already happened in some applications before.
Yeah, so that's a very good question to address. And we usually assume they're talking about the latest version, everybody install the latest version. They might, in rare cases, and like newer version, they request probably more permissions. That could happen. And but we didn't see that's a major problem, so we didn't actually consider that. I think that would be something we maybe should think about it to see if that's going to impact the effectiveness of the model. If they're if they're different versions and that they have different versions have different decisions, it may be rare, but I don't know how rare that is.
Yeah. Okay, I can hand over back to Professor Paul, maybe.
So when you do such analysis, does machine learning play a role? Do you see an importance, or do you apply already machine learning algorithms for something in your problem space?
Yeah, you have a question for me?
Yeah, you heard me or not? You hear me?
What was the question again? Sorry, I was.
The question is, so when it goes to analyzing lots of data, like in the case of the reviews, machine learning can be one technique that is interesting. And the question is, in which way do you see it as beneficial or non-beneficial to add machine learning algorithms to the schemes that you showed?
I think the scalability, right? So if you use machine learning, you potentially can handle analysis of large amount of data, and that can be automated. Yeah, I think that's definitely a benefit of the machine learning. And I think machine learning maybe have a disadvantage, like maybe lack of flexibility, and maybe the data could be misleading. For example, some data maybe mislead the results, and maybe some inaccuracy. You prefer, if the machine learning making very bad recommendations, probably you shouldn't use it if its efficiency is not very good. There are some limitations as well. Yeah.
Okay, cool. And related to both approaches that you showed, so the DDoS and also the collaborative security policies and assessments, what is the role of privacy in this research? How do you address privacy? Where do you see the risks for privacy? Can you elaborate a bit in that direction?
The privacy for the smartphone, right?
For both, because for the DDoS, it's also privacy, I would say, in a different manner, because there you might have companies that don't want to share company secrets, for instance. So it's like not the privacy of the individual worker, maybe, but the privacy of the company, the secrecy of the company.
Yeah, the privacy, it's a difficult problem. For the DDoS collaboration one, it is kind of difficult to address. At the beginning, I said that my assumption is the collaborators, like for several domains, they do not mind to share data with each other, because as long as they are not competitors, they can sign an agreement so that they do not leak the information of each other. I think that's we trying to avoid that the privacy problem. So that way, when they choose collaborators, they should choose the collaborator which they do not have any concern to share data. Yeah.
Okay, cool. And do you think collaboration is something we'll see more in the future?
Collaboration is an alternative solution, I would say. I think still, in the majority, I think they could choose to use other more mature solutions, like the cloud-based DDoS filtering. I think that's pretty mature these days, that they can use that. But as a collaboration, I think it's an alternative solution if they have concerns. For example, they found that cloud-based solution gonna create a lot of delays, and they're probably trying to see if they have any different ways now to do DDoS mitigation. I think that just like for us, I think we're not trying to replace the Cloudflare. We're trying to make it another option for the consumers.
Okay, cool. Then I would say let's close here, and thanks again for the great talk. It was cool for many reasons. So first of all, because we covered two very important topics or areas. Plus, also, I'm always a very big fan of these collaborative approaches, as you also know, and therefore, for me, it's great to see how they spread more and are used more and more. And so, therefore, thanks a lot, Carol. It was super great. Thank you very much.
Yeah, thank you for inviting me. I think it was great, and to have a chance to communicate with you guys. And I had a lot of great questions. Actually, gave me some ideas as well. Thank you.
Perfect. Yeah, thank you. And also big thank you to Alex and Erkin for such great moderation of the questions, and to Leo and Renzo, who were working on the background in the different platforms. So yeah, that closes the 14th edition of the Cyber CNI Talk Cyber CNI speaker series. Of course, everything continues. In 1 month, we see each other again if you're interested. So subscribe to the channel in order not to miss it. Subscribe on the website, and if you have further questions to Carol, you can also contact us or Carol directly, and she'll certainly be happy to communicate with you. In 1 month, the presentation will be on the 23rd of February, again at 5 o'clock Central European Time, and there we'll have Soumya Manerye from Trasna, and he'll be talking about securing the Internet of Things, lattice-based crypto and side channel attacks. And this will certainly be exciting again, so please tune in, stay healthy, and as usual, you will see the trailer now, and at the end, all the dates for the upcoming editions throughout the year, because we have lots of highlights like the one today. So yeah, it was a pleasure having you all in the audience, and see you in 1 month. Bye bye.
Thank you. Bye.
secure electrical vehicle charging systems. We will find a use case for the narrowband IoT, and we'll discuss the lattice-based cryptography, which is a part of post-quantum cryptography family, and we'll see the flexibility and scalability will be great.
Cher cyber-CNI, pôle d'excellence région Bretagne. Au revoir et à la prochaine.